In this part, we're going to be working with cube roots, or the third root. So it's going to be the same process, but as I stated before, when we're working with cube roots, we're going to be working with different sets of numbers. So it's going to be different numbers compared to perfect square numbers. Here we're going to be using perfect cube numbers. Now, as you're doing the cube roots, even though we have positive number, the concept can apply if they were negative numbers, as long as you understand the concept of when you have three negative numbers multiplying, the end results are negative. So for example, negative times negative is positive, positive times negative will be the outcome of negative. So be very careful when working with cube roots or third roots if you have negative numbers. So be extra careful. Now let's take a look at the first radical expression. We have the cube root of 16. So I can break 16 down into 8 and 2. So we're going to have the cube root of 8 times the cube root of 2. Now the reason I'm using these two factors is because 8 is a perfect cube number. Putting my plus down. Next, I'm going to simplify the cube root of 250. I can break that down into 125. So the cube root of 125 times the cube root of 2. And the reason I'm using these two factors is because 125 is a perfect cube number. Alright, so let's simplify each respective part. So the cube root of 8, that will equal to 2. And then I cannot simplify nor do the cube root of 2, so I'm going to bring it down, put it right here. So when I simplify the cube root of 16, I get 2 cube root of 2. Put in my plus sign. Next, simplify the last radical expression. The only thing I could do the cube root of is the 125, which will equal to 5. Can't do the cube root of 2 nor simplify, so I'll bring it down and put it next to my 5. So they both have the cube root of 2, meaning same radical with the same index and same number inside. So that means that I can combine the outside number. So 2 plus 5 is 7, the cube root of 2. So be very careful. Do not forget your index. If you're working with cube root or third roots, then your answer should have third root, unless you're working with different radicals, which in this case we're not. But here, if you start off with the cube root, then your answer should end up with cube root unless you had a perfect cube number, or you were able to do the third root of a perfect cube number. But here, our final answer is 7, the cube root or the third root of 2. In this example, we have the third root of 192 minus the third root of 24. So they're not in the simplest form, meaning that maybe we can break it down into factors where each of them have a perfect cube number. So let's take a look at the first one. The third root or the cube root of 192, you can break it down into the cube root of 64 times the cube root of 3, because 64 times 3 will equal to 192. Bring down my minus. Now for the cube root of 24, I can break it down into the cube root of 8 times the cube root of 3, because 8 times 3 will equal to 24. Alright, so let's simplify each radical expression. You can do the cube root of 64, which will equal to 4. I cannot simplify nor do the cube root of 3, so I will bring it down, put it next to my 4. So I simplify the cube root of 192 into 4, the cube root of 3. bring down my minus. And then for the second radical expression, I can do the cube root of 8, which is equal to 2. I cannot do the cube root of 3 nor simplify it. I'm going to bring it down and put it next to my 2. So when I simplify the third root of 24, it became 2 third root of 3. Now since both of my radical expression have the cube root of 3, that means that I can combine my outside number, 4 minus 2, which is 2, and then carry the cube root of 3. So that would be my final answer. Let me box that up. So as stated before, if you're working with cube root or third root in the beginning, most likely you might have it in the final answer, unless you were able to, if you had perfect cube numbers, then you should be able to do the third root, where you just only have whole numbers without radical expressions. But in this case we didn't, so we had the third root of 3, so in our final answer we had the third root of 3 with the 2 on the outside.